Hello everyone, this is EE542 Teamwork Lab 4, and in this lab we have to design a reliable UDP file transmission protocol, and we have some testing conditions, and we test our protocol on those conditions, and our goal is to optimize the transfer of a 1 gigabit file between two nodes connected via router with simulated network impairments. So before we get started, we have some fundamental thinking. That is, we have to send the file in parallel. We use the pthread. We divide the file into several packets, and every packet needs a sequence number for acknowledgement. But how do we determine the size of each packet and how to sequence the packets? And most importantly, how many threads do we need? And also for the resend strategy, we have to calculate when to resend, and we have to design the receiver. The receiver must be in parallel too. So before we send the file, we have to measure the RTT, and we let the sender send the packet with no data, and the receiver will send back the packet with the same format, and we can measure and set the RTT for the file transmission. So for the sending side, we have a 1 gigabit file, and we divide it into different packets and sequence it. We sequence 1, 2, 3, blah, 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 and we send in parallel with threads. Similarly, for the receiving side, it comes in numbers of sequence of packets and which receive in parallel, and the receiver will resemble the packets into the file and write the file with offset. So for the program design, we build a program to use multi-threading, handling multiple connections or streams concurrently. We have to ensure to handle packet loss and retransmissions efficiently. And we implement the program in a modular manner, separating concerns like network handling, file in and out, and error checking. And we implement the file transfer using TCP sockets. And we ensure to timestamp the transfer from when the first bit is sent to when the last bit is received. And lastly, we use the MD5 to verify the integrity of the transferred file. So here are some cases we test our protocol. We have case 1, 2, 3 with different round trip time and packet loss rate, and also the link speed. Here are some key aspects to address. Firstly, the reliability. We have to make the protocol reliable, and we have to optimize the performance of the protocol transmission time, and we have to adjustment the MTU to 1500 and 9001. And we have to compare the performance of our program or protocol and to the others. So that's it. So let's check our codes. So for the client code, we designed several functions to print the timestamp, to threads of sending files, and thread of receiving files, and threads of computing the RTT, and that's the basic design of the client. And for the server, we designed the timestamp, thread of receiving the file, and that's the server. And we have the generated file. We can use this file to generate a 1 gigabit file using random letters. And for the MD5 check, we have this check file. And also we write a make file for the make. So for the testing of the conditions, I have tested three conditions, three cases, like uh, for here, this is case 1, and I have completed the sending files. And for case 2, it's right here, you can see. And for case 3, I configured the altitude to 200 ms, and it's completed. So for the performance of our protocol, I have to firstly delete those settings of our environment. And we had to remove the output txt and rerun the server. Now it started, and we run the find. See the file sending. We got different threads, and it looks like it takes about 40 seconds to transfer a 1 gigabit file. So the transmission rate is like 25 megabits. And now we check the MD file. You can see the output text is here. Now we check the MD file.